Good morning, dear students, teachers, and science lovers on our YouTube channel. I welcome all of you for this 28th episode of Weekend Science Series, where you will learn today how to cut dosa into maximum number of pieces. Yes, today's session will give you the knowledge of combinatorial geometry, which includes the aspect of topology, even graph theory, number theory, and other disciplines of mathematics. For this, we have got the resource person from one of the renowned institute of our country, that is Chennai Mathematical Institute, which is located in Chennai. It is an autonomous institute founded in 1989 and is a center of excellence for teaching and research in mathematical sciences. Chennai Mathematical Institute, that is CMI, occupies a unique position in Indian academia and offers BSc, MSc, and PhD programs in mathematics and allied subjects. The research groups in mathematics and computer science at CMI are among the best known in the country. And yes, we have Dr. Priyavrat Deshpande, who is working as assistant professor at CMI. Dr. Deshpande has done his doctoral studies in mathematics from University of Western Ontario, which is in Canada, way back in 2011. He post-graduated from the same institute, and as far as his areas of interest is concerned, he works for arrangements of hyperplanes, algebraic topography, topology, and the applications of topology. So, with great honor and pride, I request Dr. Priyavrat Deshpande sir to start this session. Yes.
Uh, Thank you, Govindaji. Good morning. Good morning, everybody. Thank you for this kind introduction. It's a pleasure to be here, interacting with the students and well-wishers of the Bajaj Science Center in Varda. Right. So before I begin, let me just say a few words about next hour or so. So I even though we are on a virtual platform, I would like this session to be as interactive as possible. So I would not mind if I've been interrupted. So please feel free to ask questions and also to participate. So you probably have been told that I'm going to ask questions, but these are not really questions to judge you, but mainly for the participation. So this is going to be a two-way street. I would like to know your input. So we will begin with something a bit non-mathematical, and I would like to understand your views on those issues or whatever those topics, and then as we progress in the talk and start doing mathematics, I would really appreciate if you can do that. And so it'll be great if you have pen and paper, pencil and paper, something where you can do the rough work and if needed, and participate in this session. Again, language is not a problem. So if you want me to explain something in Marathi or maybe in Hindi, I'm perfectly fine with it. Uh, okay, so just feel free to interrupt me anytime. And also, I would encourage all of you to participate. So with that, I'm going to share my screen, and I haven't prepared slides. I'm going to write and we will see how it progresses. Okay, so let's start sharing my screen. Broadcast. Okay, right. So today's talk, at least the title, I hope this is visible. Am I right?
Yes.
Okay, thank you. Yeah, so today's talk, at least the title is about cutting dosa so that you get maximum number of pieces. So here, sorry, I have to apologize. There is no real dosas I have that to offer, but in future, if you come down to Chennai, I promise that I'll give, like, I'll treat you with South Indian delicacies, right? So let's pretend that we have a dosa and then we want to cut it so that we get maximum number of pieces. But the thing is, the cuts have to be straight line cuts, right? I don't expect people to just bite off pieces and uh, but we want to do straight cuts. So here is one example, but unfortunately, this is not the maximum number of pieces. So we want to understand this, right? Okay, so with that, all this food analogy ends right here. And what we want to understand really is the problem, is the following problem, where we have some straight lines drawn in the plane or on a piece of paper, and we cut along those straight lines so that this plane or the piece of paper uh, is cut into various pieces, and we would like to count the number of pieces. Okay, so here is a beautiful uh, arrangement of 24 straight lines in the plane. And interestingly, if you look closer, you'll see that all the pieces are triangular. Okay, you see all these pieces are triangular. Right? This is a triangle, so there are these triangles in between. There is these triangles, so it's a beautiful pattern, right? Not all patterns are this beautiful. So you may ask what happens to this, right? This is an unbounded region, and uh, why is this triangular shape? So that's little hard, but if you have heard about something called as projective geometry, then in projective geometry, two parallel lines meet at infinity. Okay, so then these will converge uh, at far off at infinity and will form a triangle. So anyway, so there is way to make this precise. But anyway, this is not a part of today's talk. Maybe we can talk about this later. So we are really interested in how many pieces, right? So this is 1, 2, 3, 4, say 5, 6, 7, 8, 9, 10, 11, 12, so many pieces, right? So we are interested in counting these pieces. And so these are 24 lines. And the question that we want to ask is the following. If I draw 24 straight lines in the plane, or if I do 24 straight cuts to a piece of paper, what is the maximum number of pieces I would get? So is this the way to cut so that I'll get maximum number of pieces? This is sort of the question that we will try to answer uh, in this talk. Okay, but again, this talk is a tool, or this particular question is a tool to convey something completely different. Okay, so let's forget about this question for next, say, 5 to 10 minutes, and I want to understand something from you. Okay, so my first question to all of you is, according to you, how does one do mathematics? Okay, sorry. Okay. May sound a pretty vague question, but uh, as we progress in the discussion, I'll make this question more precise. So here is my question to all of you. According to you, how does one do mathematics, or how is mathematics done, or how is mathematics learned? Right. So that's also, how do you learn mathematics?
Yeah, you can reply. Agastya.
Yes.
Yeah,
Yes,
please
sir.
go ahead. Yeah, go ahead. Go ahead.
Sir, we learn maths by solving problems,
Okay.
and it works in our daily life. Use maths in our daily life. For example, we are buying fruits, we are buying vegetables,
Okay.
and etc.
Okay. Okay. Anybody else? Yes, just go ahead. I mean, because since I'm writing, I cannot see who has raised a hand, or I don't, I'm not watching videos. So if you have an answer, just, and nobody's speaking, just, start talking.
So from every
Okay. I think we lost that person.
like sir, we are working at objects in our doing, and then and then sir we have to change our direction. So by how much distance I will change my direction and so on.
Okay. So I would still
Sir,
classify that as
even
some.
my
Sorry. Go ahead. Okay. So I would probably classify that as some real life exposure. Okay. Anybody else wants to pitch it?
Rutuja.
Yes, sir. Sir, we take daily life exam
Okay.
and try to solve them with principles.
Okay. So okay. So I'll make this as a part of solving problems, sort of studying solved examples. Okay. Fine. Anything else anybody wants to add?
Navi.
Sir, it can be learning the best way by observing people carefully.
Sorry, by observing.
Sir, by observing nature and our surroundings.
Oh, okay. So you're saying observing the nature, because I all like twice I lost what you said after observing. Would you mind repeating?
Favorite sir.
Yeah.
Are you getting echo?
No. I think she probably mumbled. So I heard the sound, but I could not make out what exactly she said.
All of us are getting echo.
Oh, really?
Yeah. Can you reconnect the device?
Okay, fine. I will just uh, I will move out and reconnect. Okay, sure.
Let us check the thing.
Yes.
It was from his end only.
Yes, I'm back. How is my sound quality from my side?
From your side, there is no issue. Now it's okay.
Okay, fine. Okay, so I need a privilege to share the screen.
Yeah.
Right. So yeah, let's go back. So someone was saying about observing something. So I could not understand what was said after observing. Would you mind repeating, please?
Yes, sir. I said it can be learned by observing our surroundings and nature carefully.
Oh, okay. So can you give me an example?
Yes, sir. Say, for example, even if we talk about trees or their canopy, we can see that they are spread over a specific area. We can
Okay.
see that it can be well observed in nature.
Okay. But then how do you learn mathematics from this observation? I mean, I'm not contesting your viewpoint. I just want to understand it better. That's my point.
Sir, I think when we observe things carefully, we get a different dimension in our brain, and then we
Okay.
can develop it and find some mathematical dimension to it.
So I mean, I would really like to understand this, but this is a bit abstract for me. Can you make it more concrete with an example? So, I mean, can you give me a mathematical concept or a mathematical skill that I can learn by observing something from the nature? You have an example on you?
Yes, sir. Sir, actually, the skill of geometry, like
Okay.
when we are in nature, like hills or trees. So, if you observe carefully, there is a certain symmetry that goes on.
Okay.
Nothing is unequal, and
Okay.
there's also this divine or that golden proportion which works. So,
But
nature
then,
is also systematic.
but then how do I understand that? Like, how do I express it? Like, see, I'm just observing. I have no idea what your term golden ratio even means. Then how do I get that? How do I express that? You understand my difficulty?
Yes, sir.
Okay, I saw some trees and I saw beautiful patterns. But then how do I from that stage to whatever this golden ratio that you mentioned, how do I go from this beautiful pattern, observing a pattern, and saying something about or whatever you saw? You probably mean to you can use mathematics to uh, explain that symmetry. So how do I do that? That's what is not clear to me. Or I saw it and then something, I learned mathematics. How does that happen? That's what I'm curious about.
So, actually, I'm getting your question.
Okay.
But
Yes,
I'm
Sure.
not able to exactly tell.
Okay. No, fair enough. Fair enough. We are just asking questions to each other. So there's nothing right or wrong, and we're understanding views. Okay, excellent. But I think it's a very, very interesting point. Anybody else wants to add to this discussion?
yes.
Yes, go
Sir,
ahead.
by
Yes,
solving our daily life problems.
yes. I think somebody already mentioned that. Yes,
Sir, may
solving
I?
problems from the textbook or real life problems. Yes,
So,
yes.
No, sir, not that. Our daily life problems means, for example, like taking a pizza box. Suppose
Yeah.
we, yes, sir.
Yeah, that's the second thing I mentioned. Some real life exposure. That's what I meant by it. Somebody said, about shopping. So yes, agree. Yes. Any
so
other point? Yeah.
Sir, may I?
Yeah,
sir, I
sure.
would
Go ahead.
like to give. Sir, I would like to give examples on that observing nature point.
Yes, please
Sir,
go
may
ahead.
I
Go
tell
ahead.
you?
So, as we know, the bigger the trees, the more the leaves grow. So, it can be an example of progression, arithmetic and geometry, and
Okay.
also how shadows work. The
Okay.
It is a trigonometric ratio in between height and the base.
Okay. 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 Excellent. Somebody else
Sir, or
wanted to
a
say something.
Yes, sir,
honeycomb.
may I?
Yes. Yeah. Go ahead. Go ahead.
Sir, we can see the numbers in the sequence also from a unique shape, as we know
Okay.
as a Fibonacci spiral, which again we
Hmm.
can see in nature in the form of shells and the shape of hurricanes.
Okay. but then that is sort of like, oh, who here has analyzed shape of a hurricane? Like I haven't done that, and I don't plan to do that either. Yeah, but I mean, you're making valid points, but for me, those are still at a distance and
Cells we can
abstract.
see.
Sorry, what did you say?
Like shells.
Yeah, shells you can see, but again, my question is, how do you express that? Like I saw a shell, and then how should it click to me that this is a spiral and this is how I should express as some sequence or some constant or something? How do I go from observing to making that conclusion?
A sequence of numbers of unique shapes are there, also known as fibogony spiral, which we can see in nature in the form of shells.
No, I understand what you're saying, but how do I make the connection if I don't know this? See, you know this because you probably read it somewhere, right?
Yes, sir.
So if you hadn't read it, then how would you have like done that? Yeah, so I'm asking a slightly different question here. I understand, but I could not resist. Right? But is this how you learned math in school?
Sir, practice.
Okay.
Practice.
Yeah, solving. I'll still call it solving problems.
So
Yeah, that's right.
about some real life exposures.
Okay. Okay. Yeah, so that also I think I mentioned. Okay, so I think we've spent enough time on this. So let's move on to a different, not different, a related question, which is, how have you learned math in school or so far, school or otherwise, doesn't matter. So till this date, how have you learned mathematics?
Practicing.
Okay, practicing.
So reviewing
So there was
our
something taught to you that, okay, this is a concept, this is how one gets at the solution, and now do 100 problems like this, right?
Yes.
Okay. Anybody else wants to add a different aspect to this?
so reviewing our errors.
Okay, so learning from mistakes. So basically doing a lot of work and learning from mistakes. Okay.
Learning everything step by step.
Okay.
Sir, the normal problems like we are finding volume, we are finding area.
Okay.
We were taught from the craft papers and the shapes,
Okay.
of shapes and straws, etc.
Okay. So
May I?
Sure, go ahead.
So may I?
Sir, it is also regularly and developing understanding of numerical relations.
I didn't understand what you mean by that. Would you want to elaborate?
Here, the best way for us to know about maths fact is by using a regularly and developing understanding of numerical relations.
Oh, okay, okay. So I would still qualify. Classify that as practice, solving problems, be in touch regularly. That's what. Yeah. So I want something different from whatever has been said till now.
Sir, applying
Wait. Yeah. So go ahead. Applying
maths to our daily problems.
Yeah, that also has been said earlier.
We can apply mathematics outside the classroom.
Yeah, I think I would still say that is a similar. Yeah.
Sir,
Yes, somebody else?
learning the concepts and learning how the formula was derived from a thing and how it was discovered.
Okay. How something was discovered.
Sir, may I?
Just 1 second. So the person who said one should learn how some concept or a technique was discovered. So can you give me an example, a personal example
Sir,
where
may I
you
give an example?
wait. So I'm talking. So can you tell me your example of this process that you learned something by understanding how that concept was discovered? It's okay. I mean, if you don't, if you haven't experienced it, you can just say so, and we can move on. I just want to understand.
Sir, may I?
Wait, I mean, did you say this,
No.
or there was somebody else? Okay, fine. You go ahead.
Sir, as we have formula in mathematics 2 by r, so it has a great derivation because of this formula.
Sorry, what format? 2 pi r.
Yes, sir. 2 pi r has a. There is a method by which that formulas came in mathematics.
Okay. So did you learn this formula
No,
using?
it's a very good. No, I have not learned it.
No. So I want something personal. I don't want some red knowledge or whatever red information. Okay.
Sir,
so
may
let
I?
me. Yeah. So this is the last thing, and we'll move on to next. Yeah. Go ahead.
Sir, by observing patterns in surrounding and study them to get something.
Can you give me an example of this?
Sir, like when
Personal example. First hand experience. Do you have a first hand experience of this? Yes.
No, sir.
Okay. So then what were you going to say? Yeah, go ahead. I finish your
So
point,
like
please.
when I think Pythagoras theorem was discovered, that time that scientists have observed something, that there is a pattern of that the sum of squares of two sides is equal to the square of third side. So he has found a pattern 2-3 times in the surrounding, then he studied it, and then he found that yes, there exists a pattern.
Okay, but that is all speculation, right? We don't know for sure. There is no written history, but that's probably how it would. But do you have a first-hand experience of this process? Have you experienced this process?
So
Even
like
suppose now you know that, right? So have you gone uh, in real life? I mean, gone outside the classroom and taken a scale and figuring out, okay, this must be a right angle triangle, so, or this must be a right angle, so let's do this observation whether or not it is true. Have you done that?
so first-hand experiences. When you take two sides of a triangle, it's always greater than the third side, or else the lines won't meet. Like whenever you try to draw a line,
Okay, yeah, that I think is valid. But have you observed this in nature? Right? Because I mean, most of you are saying about this observing in nature, pattern observation, learning something by understanding how that
Sir,
concept was
when
discovered.
we
Yeah.
Sir, when we studied that Pythagoras theorem in school, after that we try different objects. Like after studying it, just after that, we take our notebooks, textbook, and then measure it length and width, and then measure it diagonal, and then calculate that is it working or not.
Okay. Fair enough. Excellent. So if I were to compare, since we're talking about this observation, and so okay, so let's try to wrap this up in 5 minutes. Can if you were to compare learning and a genuine experimental science like biology or physics or chemistry as opposed to mathematics, uh, what according to you are some important characteristics of mathematics which make mathematics different from these experimental sciences? So if my question is not clear, let me start by saying what I think. Uh, So I think mathematics is different from these other experimental sciences in this aspect, that it is what I would call codified or clarified by logic. Okay. So there is always a logical framework. For example, doing Euclidean geometry, you have this, postulates, right? Two parallel lines never meet, two straight lines meet at a single point, something like so. So we have a pretty rigid framework, and whatever we have to do, we have to do in that rigid framework. Okay, so this is what I would like to say is a peculiar characteristic of mathematics. You guys have something that you would like to add? Yeah, so I would like to finish this part of the talk in next, say, 5 minutes or so.
Sir, maths is different from the other things.
Yeah.
As here we need as here we get the proof why it's happening.
Okay, there is a proof. Yes,
sir.
And the proof is absolute, right? It's not that
it can't be changed.
Yes, it's not like the proof of the Pythagoras theorem is valid only up to 2020 and then it changes, or it's valid only on Earth and it is invalid on Jupiter, right? It's not like that. Excellent, guys. Yes,
Sir, there are exceptions.
Sir,
there are no exceptions. So what do you mean by that?
Means, sir, a particular theorem or some proof acts on all the cases.
Yes. So if you make a statement, then if you have a proof of the statement, then that statement is true. Correct? There are no exceptions. Or you have to mention that this is true only under certain conditions, criteria, right? It's not like it changes. Yes, agreed.
Sir, we can express mathematics as a language for other subjects by which we can express our ideas.
Okay, so this is some really difficult words. Can you compress it in simpler words?
Sir,
so you're saying mathematics is a language. Yeah, go ahead.
Yes, sir, language for other subjects.
Okay, it's a language. So I probably understand what you have to say, but anyway, go ahead. Anybody else wants to pitch in?
So if science tells that how the world is made, then maths tells that how the world is going on.
Okay, so this is like way more abstract. I mean, this is beyond my understanding. You want to break it down for me?
So means we have learned in science about that Big Bang theory and much more. I mean, science has told us how the world is created, and math is telling us how the world is going. Means if we get to know all over the surroundings, there is everywhere there is maths, and this is what telling us how the world is going on.
Okay, I mean, these are still some difficult words for me. I really need a concrete understanding of, or I mean, okay, this sounds really nice, but okay, so I'll write this, but I'm not sure. So this is different from math as a language. Not sure what to write. Okay. Anything else?
Some maths helps us to predict certain things.
Predict.
Which are formulated by science.
But so you can't do prediction in physics?
Yes, but for physics, for us to predict in physics, We do need maths.
But that is basically it's a tool, right? So
Mm.
you observe some phenomena, you form a model, and one aspect of that model is some equation, or you use some sort of math terminology. So it's basically just a tool, right? But the concept is physical. So I don't understand how you differentiate this. Like it's not because of math that you are able to predict, right? Uh, Math basically just provided you a vocabulary to express your prediction. Again, I mean, if you could talk about specifics, then I can understand. But if you're talking about general thing, then I'm not sure I understand what you're saying. Okay, so okay, now I really want like first-hand experience answers, not something from a book or something. So sorry, in experimental sciences, usually the first step is observation and or pattern recognition, right? Maybe it biology, may it be biology, physics, chemistry, even subjects like humanities. You try to you do a lot of observations and try to find a pattern, right? That's usually the first step. Then usually there is a step which I would like to call as conjecture formulation. By looking at patterns, I want to say that something is true, right? Or I see a pattern that there are these two-legged creatures who have two eyes, and I saw like 1,000 people or whatever, 1,000 creatures with two eyes, and then I make the conjecture that every creature like this on this planet has exactly two eyes, right? So that's what I would call a conjecture formulation after making this observation, right? Then experimental evidence. So what we do is we have this laboratory set up, and then in the laboratory we try to mimic that particular situation as real as possible, and by making some variables fixed, we do these experiments to figure out whether the conjecture that we have formulated is true or not, right? And finally we come up with an evidence, right? Or something says that, oh, because of this our conjecture that we formulated is wrong, or so evidence either way, right? So it's either way. uh, so either it supports our formulation or it disproves, right, our formulation. So my question to you is that do you have first-hand experience of learning a mathematical concept using these four steps in an order, or in precisely this order?
No.
Anyone?
No.
Okay. I'm just going to wait for like 20 more seconds. Okay. So my point is that mathematics is not really different from whatever other sciences. Okay. It could provide vocabulary for other subjects to express their findings, but it's not. Yeah, I agree that it's codified by logic. You always need a proof. The proof, the statement. If the proof is right, the statement usually has no exceptions. There are several other things also. And anyway, so yeah, so maybe I've spent more time on this, but it's okay, right? So maybe in the remaining time, I would like to convince you up to some extent, or at least show you how you can uh, discover mathematics using these 4 steps. Okay, right? So for that, here is a question. What is the maximum number of parts formed by removing n straight lines from the plane? Okay, this is my question. I hope the question is clear. So the first thing to, how would you approach such a question? How would you such a problem? Anyone? I hope you haven't seen this in school, and hope that not many of you know what the answer is. Otherwise,
Sir, by taking different values of n and finding patterns.
okay, so let's do that. So okay, so let's say let n equal to 1. Okay, then can anybody tell me what the answer is?
2 parts.
Okay. Why?
Sir, when we draw a straight line on a plane, so it divides it into 2 parts.
Why 2? What are those 2 parts?
Half
And
of
so,
the plane,
sorry,
halves of the plane.
what do you mean by half of the plane? I don't even know like what is full of the plane. Then how would I know what
Sir,
is half of the plane?
either sides on the line, either sides of the line.
But I just know line, right? What do you mean by side of a line? See, I pretend that I don't understand any of your intuition. Then you have to convince me without using your own intuition, something which is neutral. What do you mean by side of a line? I didn't even know that line had sides.
Sir, I mean to say that if we take a plane and if we draw a straight line, so on the either sides means on the right side and left side, they means 2 parts of the line will form.
But what do you mean by right side and left side? I mean, where did right and left come? I didn't even know that right and left were mathematical terminologies.
So may I explain?
Sure.
So sir, here we are drawing one line in a plane,
Okay.
and
Okay.
supposing this plane has an apple and the line has a knife, means if we cut that from the middle, means
Okay.
the apple is cut into 2 halves, means the 2 parts are adding identical to each other, means they both have the same dimensions and volumes and etc and etc. So that's
Okay. So, but then you're bringing in new terminologies, and I'm still struggling with the basic thing. Like, what do you mean by volume? I have no idea. I am a creature that lives in the plane. I have no idea what you mean by volume. You are introducing undefined terms and just scaring me. Like, what is knife? What does it have to do with the plane?
Sir,
Again, you are using your own intuition,
Sir,
which
may I
I
tell?
don't have.
sir,
Yes.
sir, suppose sir we have a plane, and sir if we
Okay.
draw a straight line on it,
Okay.
so then sir it will be divided in 2 equal parts, 2 equal or unequal parts.
But what do you mean by how do I measure whether they are equal or unequal? Like, what is the measure of equality?
So we are assuming that that's whether they may be equal or they not be equal. We only did two assumptions, no?
But based on what? Like, how do I even what is like how are you able to measure? I mean, I don't understand how this measurement suddenly appeared here. I just want to understand that if I remove one line from the plane, then plane splits into two parts. I just want to understand the statement. Like, I don't understand
Sir,
where equal in unequal comes from. Yes.
sir, may I try to explain?
Yeah, sure.
Sir, if we consider a plane as a playground or a ground,
Okay.
and
Okay.
if we consider the line as a rope, so if we
Okay.
place that rope in order to
Okay.
make a boundary, so there will
Okay.
be two sides with that boundary. One which comes inside the boundary, or the other which we will term
But
as it is coming outside the boundary.
but uh, but then see, I'm talking about straight line in a plane, and you're explaining it to me using your own intuition. But then somebody said right and left. Now you're saying inside and outside. Like, how do I make
Sir,
sense of this?
sir, or on a plane, if you draw a line, on one side of the line, you can put some mark or something, and then means the line is cut. Then, sir, there will be two choice that we have, one with mark and one with no mark.
Okay. But how do you
Sir,
make
may
this
I to
more
explain?
mathematical? How do you express it in terms of equations and things like that? Yes,
Sir,
go ahead.
Sir, can this line be parallel or non-parallel?
I mean, there is only one line. What is parallel and non-parallel here?
Oh.
Parallelity comes when there are two lines, no, or more than two. There's only one line. Yes, somebody was trying to speak just before this.
Yes, sir. May I try?
Yeah, go ahead.
Sir, we had a plane. Sir, we consider it as a ground, or we can say a paper. Sir, we
Okay.
can put we put a line in there. Sir, after that, you tell us the 4 points. We observe it first. Sir,
Okay.
after observation, we do experiment on it. Is it equal or unequal? We place both the pieces of paper on each other. If these
Okay.
papers are equal, then sir, it means, sir, the line is in middle, and sir, we had done two equal parts. And sir, if
But
the
see,
measurement,
okay, but the thing is, I don't understand why are you guys obsessed with the measure. I just need two parts. I don't care whether they're equal. One could be very small, one could be very big. I don't care. I'm fine with whatever division. And the thing is, plane is infinite, right? It's an infinite set of points. So then why are we obsessed about having equal parts and even trying to measure whether we have equal parts or not?
Sir, or that only one side with mark and other side with no mark.
Okay. So how do you express a line on the plane mathematically without any intuition?
With the help of an equation.
Okay, excellent. Okay, somebody said equation. So what is the equation? What is an equation of a line? Like how does it look like?
For we give value for coordinates.
Okay. So suppose I have a straight line. So I mean, this is just part of the plane. Huh? Even though I have drawn a blue bounding box, it's you have to consider that it's infinite. Okay. Suppose this is my line M. Okay. So have you defined line as the locus of ax plus by equal to c? Have you defined line a line like this?
Yes, sir.
Yes, sir.
Are real numbers.
Yes.
And not I mean a b are not simultaneously zero, right?
Yes, sir.
Okay. So this is a line, right? Mathematically, it's a solution of a equation ax plus by equal to c. Correct?
Yes, sir.
Right? So now, suppose I've removed it from the plane. So what is plane? Plane for me is basically pairs x comma y, where x and y are real numbers. And I'm looking at all pairs, right? From those pairs, we have removed the pairs which satisfy this equation, ax plus by equal to c, correct?
Yes,
If
sir.
that is the case, then what remains? Suppose from all pairs x comma y, where x and y both are real numbers, I have removed pairs which satisfy ax plus by equal to c. Okay, so those pairs are not there. Now, if I choose, let's say this particular pair, let's say it's called,
Sir,
let's
may
call it
I?
x1y. Yeah. So what is, yes?
Sir, then there will be two types. Either ax plus by is less than c, or ax plus by is greater than c.
Awesome. See, this is something that I understand because there is no intuition, personalized intuition. X plus by is greater than c, x plus by less than c, right? These are the only two choices. Either ax plus by is bigger than c, or ax plus by is less than c, right? So if you choose 2 points which satisfy less than c inequality, then it is not very difficult to see that you can always find a line segment. You just take the convex linear combination. The line segment which joins these 2 points is completely contained in here, right? All the points on this line segment will satisfy this inequality. And this is true for any 2 points here. But on the other hand, if you take 1 point here, which is ax plus by less than c, and the other point here, which is ax plus by greater than c, and if you try to draw a line segment between these two, you will have to cross the line ax plus by equal to c, but that is not there. It has been removed, right? So this is how you convince yourself that there are precisely 2 parts. So this mark on one side, that was an intuition in the right direction, but again, it was intuitive level, right? So there is, now here, there is no intuition. I've given you the proof. If you, if you have the line equation of the line, then if you remove the line, the complement, right? The complement of the line is broken up into 2 parts, exactly ax plus by greater than c and ax plus by less than c. Is that clear?
Yes.
Yes,
Excellent.
sir.
Okay, so now let's move on. So this is the thing we have cleared. The next part of the experiment is n equal to 2. So how many pieces if I remove 2 lines?
4.
Okay. So let's say I want to find, first I want to find all possible number of pieces and then choose the maximum. So how many pieces are possible if I want to remove 2 lines from the plane?
Sir,
Sorry. Okay,
Sir,
let me
4.
actually make a
Sir,
table
3.
here.
Sir, 4.
Number of
4.
lines removed and number of pieces formed. All possible number of pieces, not just maximum. So if I remove 1 line, I get 2 pieces.
2 pieces.
If I remove 2 lines,
Then sir, 4.
yes, somebody said 4, 3 and 4. You're right, absolutely right. So I could have 1, 2, L1, L2, or I could have L1, L2.
Yes.
Right. So this is 1, 2, 3, 1, 2, 3, 4. Right. So 3 or 4. Is 5 a possibility?
No, sir.
No, sir.
Sir.
Okay. Can you prove it? Think about it. Okay. If you can prove it. Okay. 3 lines. How many pieces possible? So this is the maximum. Huh? So maximum here is 4. So this is 2, 4. Now 3 lines. How many pieces?
4 and 6.
4, 6, and
4,
7.
4, 6, 7.
Sir, 7.
5.
Sir, 6.
5, 6, 5. So I think for 4, you can draw lines like this.
Parallel.
So 1, 2, 3, 4 pieces. For 6, you can have 3 concurrent lines.
Yes.
Or you can have something like this, right? So in either case, you get 6 pieces. For 7, how do you draw lines in order to get 7 pieces?
Sir, in the six, the first diagram which you have drawn, so in that the all the 3 lines are meeting at one point. If we draw 3 lines where they are making a triangle inside also, yes sir, like that.
Okay,
Yes, sir.
so this is 7 pieces. Okay. Is it possible to get 5 pieces? Is there any other way you can draw 3 lines in the plane apart from these 4 that are drawn here?
Sir, the diagram for 2 lines with 3 parts, so we can draw one line from where 3 is beginning. Sorry, the line number 3 is beginning.
Hey, this is a line. There is no beginning. There is no end. It's an
So
infinite
means
line.
we can
It's an
draw a
infinite.
line with the diagonal between for the part 2.
Sorry, what? You mean something like this?
Yes, sir.
But this extends here, right? And this extends here, which is the same as this. Right?
Yes, sir.
Okay, so you have to convince yourself that these are the only possibilities, and 5, it's not possible to draw 3 lines so that you get 5 pieces. Okay, interesting. 4 lines.
Sir, 5, 8 and 10.
Yes, sir. 5, 8, 10.
Sure. No more. 11, 6, 7, 9.
Sir, not sure, but got this much only.
Okay, then try.
Sir, 9.
Yes, 9 is a possibility.
Sir, 6.
Oh, you got 6 parts? Awesome. Can you tell me how to draw 4 lines so that to get 6 parts? See, 5 is easy, right? Four parallel lines, 5 pieces. 8 is easy, 4 concurrent lines. 9, I think you can draw something like this.
Yes.
Right? You get 9 pieces. Okay. 10 is also, I think.
Sir,
not
2
that
parallel lines.
Yes, I think this will give you.
And cross inside it.
Yes, sir. 10 pieces are possible.
Yeah, 10. What about 11? Fine, this is fine. 10, 11. See, in all the pictures so far, you had either parallel lines or concurrent lines, right? So try to break away from that pattern, right? See here, the 3 lines. Okay. So there no 2 are parallel, no 3 are concurrent. If you can do that, where you have no 2 parallel and no 3 concurrent, I think something like this. And this. Right? So this gives you 11 pieces.
But can we make 2 lines overlapping each other?
Overlapping, then it's just one line, right?
Yes, sir. So we have only 3 lines. And by 3 lines, we can make 6 lines, 6 parts.
No, but that's what I'm saying. Then you're saying 3 lines. I want 4 different lines.
Yes, sir, we can make 11 parts.
Sorry?
Yes, sir, we can make 11 parts.
Yeah, I agree. I got 11 parts here. But what about 6 and 7? Okay, now let's make. What about 5? Do you want to try 5, or you guys are tired? You want to try 5 lines? See here, 6 and 7 are missing. Is there
Sir,
anybody
13.
who's
13.
what 30? Sorry, what? What
Sir,
answer to
13.
which
Sir,
question?
5 lines. 5 lines.
Are you telling me all possible
No, sir,
number of
only one.
pieces?
Only one outcome.
Okay, one outcome. Fine. 13.
Sir,
Okay,
one is 6.
6. Then obviously 10 because 5 lines concurrent. Right. Then
Yes.
somebody said 13. So let me 11, 12, let's say 13. Okay. Did anybody get 11 parts?
Sir, I got 6.
Yeah, 6. I also got 5 parallel lines.
Sir, I got 11.
Okay, somebody got 11.
No, sir, not like that, sir. We can make a cross and from one side one line and from other side one line. So we get 6.
Okay, it's okay. But no matter how you drew it, you got 6.
Sir,
It's okay.
14.
Sir,
14.
12.
Sir, 15.
Oh, you got 12. 15 or 16?
15.
15. Anybody 16? Okay.
Sir, 9.
Sir, I got 16.
Sir, I got 7.
Hello.
Yes, sir.
Yes,
Oh,
yes, sir.
I think
Sir?
I did not realize that I got disconnected. Sorry. Yeah. So I'll just wait till I get the. Yeah, I don't think I still have sharing privileges. As soon as I get them. Okay. Sorry, I didn't even realize that I was disconnected. Okay, so where did I lose you? Because I kept talking and I didn't realize. Yes, so is this example fine? Where you get 16 pieces when you draw 5 lines?
Yes, sir. Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So now let's make a table. So whenever I have one line, the maximum number of pieces I get is 2. 2 lines, 4, right?
Yes, sir. Yes, sir.
3 lines, 7. 4 lines, 11. 5 lines, 16. So what should be the number of parts when I draw 6 lines?
22.
Why?
Sir, because we got a series where Fibonacci number.
Sir,
No,
the
there is
voice
no
is echoing.
Fibonacci.
Sir, sir, sir,
There is no
consecutive natural numbers are being added.
But there is no Fibonacci sequence here, right? It's not
Sir,
Fibonacci.
it's a by mistake.
Sorry?
Sir, we get a pattern.
Yeah, you got a pattern. I don't care what you call it, right? 7 plus 4, 11, 11 plus 5, 16, 16 plus, you're expecting 22, right? But either you should draw 6 lines and show that you get 22 pieces, or you have to prove, correct? Right? How to prove this? So we formulated how to prove the conjecture. So what is the conjecture? Conjecture is that P of n plus 1, which is the maximum number of parts when you remove n plus 1 lines, is P of n plus n plus 1, right? That's what we've observed. Right? Sorry. So we saw a problem. We did experimentation here, and then we spotted a pattern. And now the next step is how to prove, right?
Sir,
So, yes.
sir, we had get here and pattern.
Yeah, I agree.
Yes, sir. Yes, sir.
Yeah, I agree. I mean, I just showed you the pattern. The important thing is how to, the next important step is to prove that this is indeed the pattern which continues ad infinitum. Okay, this is something we haven't done. So it may very well be true that for 6 lines you get 23 parts. Okay, I mean, we are just guessing, or we are wishing that it turns out to be 22, right? So either we have to demonstrate or we have to prove. But demonstration is not very useful, because how far are you going to demonstrate? Somebody said, oh, 1,000 lines. So are you going to draw 1,000 lines and show that the formula holds true? No, you're going to find a proof independent of drawing pictures. And yeah, so that I leave, because I think we're sort of out of time. But maybe some other time we could, or you could, I mean, it's not very difficult. You could actually prove it if you sort of think about it for like 10, 15 minutes, draw a lot of pictures, you'll actually see how to prove this. Okay. Yeah, so I would like to end with one question, is that, see, here we missed 5. Here we missed 6 and 7. Here we missed 7, 8, and 9. Okay. So my question is, can you find a pattern of the numbers that we miss.
Sir, there are seven
And
by four lines.
sorry, what?
Typical lines.
So my question is, can you find a pattern of the numbers that are missed? So you'll always get n plus 1, right? And then here is 2n, right? So the numbers between n plus 1 and 2n are always missed. So that is the pattern. So can you prove it? That is my question. Okay. Okay. Oh, seems like a cross connect. Anyway, so okay. So with this, I would like to stop, and if there are questions, we can discuss. Okay. So I know that I haven't proved that this is the thing, but my plan was not to prove this. Oh. Okay. Okay. Yeah. Yeah. So I don't know. Somehow the screen share stopped. So maybe let me try again. Right. So I basically wanted to demonstrate the following, which is this, right? Observation, pattern recognition, conjecture formulation, experimental evidence, and sort of the proof, right? The proof. Okay. Okay. So I didn't demonstrate the proof, or I didn't write down the proof, but I leave it up to you. But at least I was able to demonstrate these 4 steps. Okay. So with this, I'd like to stop, and if there are things we want to discuss, or there are questions you want to ask.
Yeah, if you have any questions, then you can go ahead. I'm sharing your screen now.
Okay.
Yeah. Can you switch on your camera now?
Oh, okay.
Students, do you have any questions to ask? Related to the topic, not related to the topic?
Sir, may I?
Yes, Mantre.
Sir, are there any similarities in the means we found that for every n number of straight lines we got different number of smaller pieces. So is there any pattern between the highest, like for 2 lines there are 4 parts at maximum? So for every like 4, 7, 11, 16, 22, is there a similarity in the diagram which we draw?
Yes. So there is one similarity, which is that in that diagram, no 2 lines are parallel and no 3 are concurrent. In fact, the proof of the fact relies on this observation that if you have parallel lines, then you have fewer pieces. Same thing happens if you have concurrent lines. So the thing is, in order to maximize pieces, you want to have more cuts. So you want to have more intersection points where only 2 lines meet. See, if you're
So
drawing
no
a
3
third
lines
line,
can be concurrent and
no 2 parallel.
Yes, thank you, sir.
Yes. Anybody else? Now you have got the idea how to cut dosa in maximum number of pieces.
Yes.
So Thank you very much, sir. We are thankful to you for giving your valuable time and making the session interesting with interactions. Hope to learn from you again on some more topics. You have been to Vardha and would love to see you again sometime.
Sure. Yeah, it will
Thank
be
you.
my pleasure to meet all of
Yeah.
you in person. So, thank you for the invitation.
Yes, thank you. With some more interesting topics, we will continue this series. And yes, take care and stay connected. With this, I would like to end. Thank you very much.